Hello students, today we are going to cover the topic of drift velocity. Now before going ahead with the topic, if you want to improve and excel in maths and science, then do check out the courses offered by Infinity Learn and don't forget to use the discount coupon code HQ10 to get extra 10% discount. Now let us come back to the topic. Now before talking about drift velocity, let us first understand what happens in a metallic conductor which is not connected to a battery. So these metallic conductors have electrons in them, and these electrons they tend to move randomly when they are not connected to any source. And if we divide this conductor by this partition, what we find is that even though charges are moving around over here, and these charges they tend to move in random motion, what happens is that net charge which is crossing this junction, it is equal to 0. Means the amount of charge that has crossed from left to right wala section is equal to the amount of charge that has gone from right wala section to left wala section. So the net charge is 0, and therefore the amount of current that is flowing, we can say it is equal to 0, because current is defined as charge per unit time. And this is what we discussed, that conductor is when conductor is not connected to a battery, the electron inside the conductor are in random motion. Now let us talk about another state when we have a conductor which is connected to a battery. Now in this case what happens is the electrons they tend to move in a specified direction. It doesn't mean that electron stops its state of random motion. Electrons still continues to move in a random direction, but what is observed is while moving in this random direction they tend to travel in a specific direction, and that specific direction can be easily understood by understanding the EMF over here. As soon as we connect the battery, there is an EMF which is set up, and these electrons they move in a direction opposite to the direction of the EMF, or in simple words you can say these negatively charged electrons they are moving towards the positive terminal of the battery, and the speed with which they are drifting or moving towards the positive terminal is termed as their drift velocity. Now, let us quickly derive the relation of drift velocity over here. So, for this, let us consider that there are electrons which is moving with drift velocity Vd, and let small n be the number of charges which is present in the conductor in a unit volume. So, if I consider a small volume over here, a unit volume over here, the amount of charges in this particular space will be considered as small n. Now, let us say that these electrons they travel distance L with the velocity Vd in time t. So time is nothing but distance upon speed. So distance covered is L, and the speed with which they are moving will be drift velocity Vd. And the section that we have marked over here is having a cylindrical shape, and if I talk about this cross sectional area, let us say this cross sectional area is denoted by A, then the volume of the section highlighted will be what? Area into length. So it will be A into L. Now what we are trying to get with this is, I want to find out how many charges are there in this particular section. So the number of charges over here will be given by charges per unit volume into the volume that we are talking about. So over here it will be n into A into L. So this gives me the count of charges, the number of charges that is present in this region. Now I have the number of charges which are present over here. Next part that I am interested is what is the amount of charge? What is the total amount of charge that is present over here? Let us denote the total amount of charge which is there in this volume as Q. So what will be the total amount of charge? We already have the number of electrons or charges in this particular section, and we know that every charge over here is nothing but an electron, and the charge of an electron is denoted by small e. which is 1.6 into 10 raised to minus 19 coulomb. Now by using this, what we can do is we can write down what is current ka equation. Current is Q by T, charge per unit time. Charge we just got as NALE divided by time we already found out over here. So it is L upon VD. Now we can clearly see that L from numerator and denominator cancels out, and we have got current flowing over here equal to NAE into VD. Or we can rearrange this to get the drift velocity as I upon N into A into E. And as we have already mentioned, the drift velocity ka direction will be opposite to the direction of EMF. Now the practical values of drift velocity is in the range of 10 raised to minus 4 meter per second to 10 raised to minus 5 meter per second. Now people might say this is a very slow speed with which electron moves. So the question arises that if I have a circuit in which I have connected a bulb, then how come the current reaches the bulb instantaneously and it turns on as soon as we connect the bulb? So the answer is very simple. For the bulb to get turned on, the electrons has to flow through it, and it is not like that ki all the electrons are placed over here. The entire conductor which is connecting the lamp or bulb over here is filled with electron, and as soon as we turn the circuit on, the electrons which are nearest to the bulb, they instantly enter the bulb and the bulb is turned on. Now let us finally talk about the direction of drift velocity, which we can get from the formula as well. So the formula that we derived is drift velocity is equal to current flowing through the conductor divided by charge concentration, area of cross section, and the value of single charge. Now over here we know that charges are of two types. So charges can be positive as well as negative. And we also know that direction of conventional current is from higher potential to lower potential. So if we talk about negative charges like electrons, for them what will happen is the minus sign that comes for the negative charge will tend to tell us that direction of drift velocity over here will be opposite to the direction of current. So if I have electrons flowing through this conductor, they will be flowing in the direction opposite to the direction of the current. If I have positive charges, these positive charges will have charge ka value to be positive, and therefore drift velocity ka direction and current ka direction will be same. So positive charges are going to flow in the direction of the conventional current, and electrons, negative charges are going to flow in the direction opposite to the direction of the current. So that is what we have over here. Positive charges, they have drift velocity in the direction of the current, and negative charges have direction of drift velocity opposite to the direction of the current. So I hope the concept of drift velocity, the formula of drift velocity, and practical values of drift velocity is clear to all. Thank you very much.